charge. Our objective is to be able to use mathematical thinking to analyze the amount of electrostatic force and electrostatic charge that exist on an object. So, first of all, I spoke about force, and we are going to be looking at the electrostatic force between electrons. So first, just a little bit of notation information, and what we have is we need to be able to say that charge, we're going to be dealing with charge, that symbol is Q. It is measured in a Coulomb, and a Coulomb is like, it's a lot of electrons. It's actually 1 Coulomb is equal to 6.25 times 10 to the 18th electrons. It's an elementary charge. E is elementary charge, and an electron happens to be one of them. And so then, like it says here, it says 1 elementary charge is the value of 1 electron, and 1 electron is equal to 1.6 times 10 to the negative 19th coulombs, and they are inverses of each other. So you can use either one. These are on page 1 of your reference table. Okay, so then this is Coulomb's law. If you notice, it looks very similar to an equation you've already had. And it's similar to the force due to gravity is equal to big G m1 m2 divided by r squared. So you can see the similarities here. It works the same way as far as the algebra goes. And in the calculator. So remember to be careful with exponents. Okay, so that's my little warning there. We've been over how to use that, but hopefully you remember how. So anyway, Q is the charge involved. That's here. You're going to have the charge between both objects, and it can be either in elementary charge or in coulombs. K is the electrostatic constant. Just like big G, it adjusts the value of the equation so that the numbers reflect what's actually observed. And for K, it is 8.99 times 10 to the 9th newtons times meter squared per coulomb squared. And R is the distance between the charges. Again, it's not the radius. It's the distance between the charges, okay? So what's the force? So say we have a proton and an electron that are separated by a distance of 1 times 10 to the negative 10th meters. What's the force on the two charges? So we have Coulomb's law, and it's Fe equals K, and it's Q1, Q2 divided by R squared. And if we plug it in, we see K is 8.99 times 10 to the 9th newtons meter squared per coulomb squared, times a positive 1.6 times 10 to the negative 19th coulombs times a negative 1.6 times 10 to the negative 19th coulombs. Remember, this is for the electron, and this is for the proton. So that's why it's positive and negative. So then that's divided by 1 times 10 to the negative 10th times 1 times 10 to the negative 10th. And then when you plug that in, you get a force of negative 2.3 times 10 to the 8th newtons. And in this case, the signs are important. It's a force, so this is a vector. So that means that the negative signs have meaning. Negative means that it's attractive, so toward each other, and positive means repulsive. And you can look at this, these are opposite signs, so they should attract. So you can double check yourself. Okay? So then we are going to move on to conservation of charge. So if you have a net neutral charge, so you have two positive, it's missing two electrons here, so it's positive 2 charge, and then this one has two extra electrons. When they come together, 2 plus a negative 2 is equal to 0. So the net charge, Q, is equal to 0, or neutral. So that means that this this electron gives up 2 electrons, and it makes it so that there are this here gains 2 electrons, and this one loses 2 electrons, but it's a net neutral charge, and this only happens when they touch. Okay, so here there's conservation of charge. We have a positive 4 electrons, so these here cancel out, and we just have these positive 4 electrons. So that means that it's missing 4 electrons to make it neutral, and this one is a negative 6 electrons. These cancel out, and we get 6 extra electrons. Oops. So that means that when you put them together, you have a positive 4 plus a negative 6, you get a negative 2 electrons, and a negative 2 charge, which means that you have a net negative 2 charge, and that just means that you have 2 extra electrons. And that means that when they touch, this is going to have a charge of -1, and this is going to have a charge of -1. And I'll show you that. So again, this is a net charge of -2, so you have the +4 and the -6 is equal to -2. They touch, and then you get -1 and -1. So it's going to move over and share an electron over here, and that happens regardless of whether you have 3 missing electrons here and -5, so you have an extra 5 electrons over here, or if that happens for any of the different iterations. So +2 and -4, +1 and -3, or a 0 and -2. What happens is that when they touch, they evenly distribute between the objects. So if it was 3 objects, you would divide it by 3. So if it was a net charge of, say, 6, and then of a -6, and then there were 3 objects, it would be -6 divided by 3, which would be a -2 per object. And you'll see that in examples as we go forward. Okay, so then what about this one? We have 5 extra we're missing 5 electrons here, and we have +9 over here, so there's a net charge of 14. So which one is more negative? This one is actually more negative, because it's missing fewer of the electrons. So that means that it's more negative. Because if you line them up, what you end up with is But then you're going to have, this is the plus 5. These cancel out, but then you have 1, 2, 3, 4, 5. And so that's a positive 5. Okay, so it's less negative than the positive 9 elementary charges. Okay, so what happens is that when they touch, the charges become evenly distributed among the two objects. So it's 14e divided by 2 objects. So it's then equals 7 elementary charges per object. So just a quick formula that's not in the reference table. It's going to be the total charge divided by number of objects equals Q per object. Okay, so this is basically conservation of charge in a nutshell. Alright, so how about this one? We have a net charge of 9 elementary charges, so it's 5 plus 4 equals 9 elementary charges. And so what would it be between the two when they touch? So it should be 4.5 elementary charges and 4.5 elementary charges. However, electrons cannot be cut in half. So this is not allowed. However, coulombs can be cut in half. Coulombs are a lot of electrons. A lot. So what you can say is that there's half a coulomb. So here you have 3 coulombs and a -4 coulombs. So it's a net charge of -1 coulombs. So when they touch, it's going to split between the two, and it's going to be -0.5 and -0.5 coulombs. This is okay. So is it possible to have 5.2 times 10 to the -19th coulombs? So you take the 5.2 times 10 to the -19th coulombs, multiply it by 1 elementary charge divided by, or 1 electron divided by 1.6 times 10 to the -19th coulombs. This cancels out. Or you can do the same thing with the 6.25 times 10 to the 18th elementary charge is 1 coulomb. I always use this one. Only because I like to stick with one thing. But you do need to know that how to convert from elementary charge to coulomb, but this is again on your reference table on page 1. Okay, so to actually do this, it's equal to 3.25 electrons. So if you say that it's equal to 3.25, it's not allowed because it's not a whole number. Okay, so then, what about this one? How many electrons is this? So we can say 1.28 times 10 to the minus 18th coulombs is equal to 1.6 times 10 to the negative 19th coulombs is equal to 1 electron. And this gives you 8 electrons. So this is allowed. And then we can move on to this one. This is 9.92 times 10 to the negative 19th coulombs. This is 1.6 times 10 to the negative 19th coulombs is 1 electron, and that is equal to 6.2. This is not allowed. Then this is 8 times 10 to the minus 19th coulombs times 1.6 times 10 to the negative 19th coulombs, 1 electron. And this is 5 electrons. That's allowed. Then 4.8 times 10 to the negative 19th coulombs times 1.6 times 10 to the negative 19th coulombs, 1 electron. And that is equal to 3 electrons. This is allowed. Okay? So that is how you figure out which types of, which numbers of coulombs actually correspond to an electron, and conservation of charge, and Coulomb's law as well. So finding the force between two charges. All right, thank you.